reaction.
Hey, this is Nick, and the problem states, what is the average reaction rate for the time period between 15 microseconds and 30 microseconds using the data below for the reaction of nitrogen gas with oxygen gas to form nitrous oxide gas? And here we have the average reaction rate equals the change of the reactants, in this case which is nitrogen gas and oxygen gas, over the change in time. So now we can go to the diagram and plug in 3.6 and 7.6 micro, and then we could plug it in here, and then you can plug in the time that corresponds to that. And we'll plug that into the calculator and get 0.266 for the average reaction rate. And for part B, it states what are the rate law and rate constant K for reaction above using the following data. So we can look at the diagram and the rate law, which is equal to the rate constant K times the concentrations of the reactants, which in this case is NO and O2. And we can go to the diagram and plug in the concentrations that correspond to find the K value. And in this case, we have to square the concentration of NO because the coefficient of NO is 2. And then we could plug that into the calculator, and we could do some algebra to figure out what K is by dividing this side by the initial rate, and we will come out to get 15.4 S squared over M squared, and we know that is the units because this is a second order reaction. And we're able to tell that because as the concentration of O2 doubles here, the concentration of NO quadruples here, therefore telling us that is a second order reaction. Just to summarize, some of the highlights for this video are just to show you what are the equations for the rate laws, which is the rate constant K times the reactants, concentration of reactants, and then how to use this equation to manipulate it to find what K is, and also how to find the average reaction rate by having the change of reactants over the change in time.